rough science from the island of Carriacou off the coast of Grenada. Based here at this old derelict lime factory, 5 scientists will be getting back to basics to try and crack a series of challenges. This is about science. It's not about survival or competition. Ingenuity and cooperation will be the keys to their success. When you're on a tropical island, you've got to learn to cope with the heat. That's a lot easier if you've got something cold to drink, but our scientists don't even have a fridge. So can their brains beat the heat? Right, guys, Mike and Mike, we'd like you to make us ice. A nice, big, shiny block of ice.
In this weather?
In this humidity?
Yes.
And you are going to help, Kathy and Jonathan, you're going to help them by making them a thermometer so we can see how close they're getting to freezing point. And Ellen is going to be the saviour of all of us. You're going to save our complexions and make us a sunblock, okay? I'm here to fetch, carry, be shouted at. You've got 3 days to do it.
Sweating is just a natural process. When you get too hot, the body produces a liquid on the surface of the skin, and that evaporates, and as it does so, it needs heat to evaporate, to go from liquid to vapour. And you get a cooling effect because it's taking the heat from the surface of the skin to enable that process of evaporation to take place.
So we're going to try and use evaporation to cool water and make ice, yeah?
Yeah, that's exactly it.
Mike Bullivant needs to get a bottle full of something that evaporates like sweat, only faster. We need super sweat. As it evaporates, it should cool down any water that's around the bottle. And Mike Leahy's trying to think of a device to speed things up even more. Something to force the super sweat to evaporate as quickly as possible.
On with the lid.
Mike B's first step is to fill a kettle with lumps of wood.
Piece of precision engineering. Feed that in there and take it over to the kiln.
He's trying to extract a form of alcohol to act as our super sweat. So what's going on here?
What I'm trying to make is some methanol by heating this wood up in this kettle. And the methanol is a solvent that boils at 67 Celsius. When it evaporates, it needs heat to do that. And so if you dropped methanol on your arm and it evaporates, you feel the cold.
So it's sort of stealing the heat from your arm.
That's right.
Some hosing.
Mike Leahy's decided to try and speed up that methanol evaporation with a suction device to force it to steal as much heat as possible from its surroundings in the process.
It uses the principle of fast-moving water down a pipe here to suck air in from a side pipe here. A little bit like the way you might feel sucked in as a fast train goes past you. This way, what we can do is suck air out of anything here. So it could be a pot, maybe with whatever Mike's got that he's made to evaporate to cause a cooling effect.
Ellen and I are off on a shopping expedition to get the ingredients for sunblock and also for insulation to keep the sun off Mike's super sweat and help that cooling process. Calabash fruits are skin soothers.
Right, we're set. You kind of tug.
Lianas to climb palm trees.
It's fantastic, isn't it?
Poo and clay to make insulation. Limes to protect the skin. Coconuts for their oil. And finally, a dip in the sea to cool us down. Sorry, guys.
The pointer for the thermometer.
Back in the heat of the lime factory, Kathy and Jonathan are playing with thermometer designs.
As the current goes to the cores, it will push it.
They'll need to register if the mics have managed to lower the temperature. And Jonathan thinks wire coils are the answer. While Kathy's trying something that looks more familiar.
Okay, I think I should be able to use that to try to make my thermometer. And it's a bit thick. I'll give it a go, just with this size to start with. I might need to try to make something thinner as well, though.
I thought we were supposed to be cooling things down.
But I have to be able to melt this glass, and I'm not sure that I'll be able to on this kind of flame.
In the bottom of the oven, the kettle of wood is bubbling away. It produces steamy smoke, which condenses down this copper pipe. The result? Brown gloop, which Mike assures me contains the alcohol methanol. Very poisonous, but just the thing to evaporate quickly. We have super sweat.
I'm just about to test the suction device for the first time.
Oh,
If
okay.
you could give me a hand, it would be really cool.
Sure.
What I'm going to do, I'm going to suck some water out of that barrel we've put up the top,
Yeah.
siphon it down, but I don't want to swallow it. Do you think you could give me a shout when it reaches, there's like a clear window in the hose?
Okay.
Can you see it okay?
Yeah, got it. Okay, Mike, suck away.
Okay.
It's coming.
Now. Please. Oh. Okay, it's working, Kate. If you want to see if the suction thing's working, there's one surefire way to tell. If I hold it together,
Yeah.
you can stick it gently in that bottle and see if it's sucking up any water.
What, this one? Okay.
Lean it over a little bit, cheat a bit more.
I'm not cheating for you. What do you reckon?
It's definitely...
It's not spectacular.
No, I think it's
But the
because it's got
theory
air.
might work. Our physicists are getting even hotter in pursuit of a working thermometer. And sunscreen. Ellen's grating coconuts. It's the end of day one. Why are we taking a ladder to the forest with us? I thought botanists could climb trees.
We're not. We're just going to collect. I saw this vine, and we're going to collect some sap for the sealant.
The sealant is for Mike Leahy. He's decided his suction pump doesn't suck because it's not airtight.
Yeah, it's a pretty strong tree that the vine's growing on.
Okay.
You going to hold it?
I'll hold it.
Thanks.
So this is going to be for the mics then.
Yeah, it'll make them
Kathy
happy.
and Jonathan.
I'm just cutting a couple branches up here, Kate, and then tying tin cans to them so the sap will flow into the can. Then we'll have some rubber-like substance.
Why don't you just pull the branches down and we decant the sap down here? Wouldn't that be easier?
If you do that, the sap stops flowing, and we need a lot of it.
Can you bring me a little bit down just so I can see what it's like?
Yeah, I'll even bring you the flowers.
Okay.
Take a look.
Oh, wow, yeah. It's definitely oozing. It's like milk or something. It is slightly tacky.
I just want to get a feel for whether this glass rod in here is getting soft at all, whether it's getting anywhere close to melting. Because I want to close off the end of that tube.
And Jonathan's still just twiddling and soaring and doing Jonathan-type things.
Is that what you need?
I need to seal up all these joints here.
Okay.
So if you've got something that will help, oh, cool.
And I've been playing with this, and see this?
All right.
As it gets sticky, and then it solidifies.
Nice one. That should be perfect.
Okay.
It's sealed, it's airtight, so will the suction pump suck.
Okay, I'm going to start sucking. Right.
It's coming!
Okay. If I give you this pot, I'd say won't clear this water. Right, what we need to do is stick that in there. It wasn't sucking earlier, so I need to do some modifications. I think it's moving this.
Let's
There we go. That's sucking now, yeah?
Yeah.
That's actually sucking quite fast.
It is.
It's just a case of grabbing this bottom pipe and squeezing it. And
Simple as that.
I've got to think of a way of doing it. Well, I've moved this jet, this takeoff,
Yeah.
and I've moved the pipe up and down, and now it's just a case of restricting the bottom pipe.
So there's better suction, which the Mikes hope will mean faster evaporation and therefore better cooling, if they ever get round to it. After 2 days of endless coiling, Jonathan has come up with an electric thermometer. When the temperature around the coil changes, the electric current should change too, and that should register on Jonathan's meter.
If I take one of these out,
Yeah,
like this one for example,
yeah.
and heat this or cool it, it
Yeah.
unbalances the whole thing. You get a voltage produced, which we can measure on here, see? And then we can calibrate that.
Oh, okay, yeah.
And as you can see on the meter at the moment, when I press it, there's just no deflection at all.
Hardly
So
any
the whole
change
thing
at
is
all.
basically balanced.
Yeah.
But if I put this in the hot water, this isn't boiling, but it's hot. That's heating up now, the resistance is changing, so I'm
Right.
balancing the electrics of this. And that should produce a voltage, and when we touch this, the meter should move here.
Oh, yes. Mike's putting the final touches to his methanol, or so he claims. And Ellen's been neglecting her sunscreen duties to get up to her armpits in cow dung and clay to make a cool box.
And then it's just like making pastry dough. The manure is like the butter, and the kaolin, or the clay, is like the flour. And we are cutting it in.
Time to test if the evaporation process can cool things down. So this is the methanol. Smells lethal, Mike.
It does.
So what happens now?
Okay.
Get some water on the outside.
Make it wet.
So we're not going to try and freeze a whole load of water at the moment. We're playing safe, and so we're hoping for a bit of a crystallisation around here.
Water, yeah.
Okay. There's all Ellen's lovely insulation, so put that in there. So what do you have to do, Mike?
Right, we've got to put that there.
So this is where we're hoping we're going to get sucked.
There we go.
Mike's suction device should be speeding up the evaporation of our methanol, and that should be causing cooling. We wait.
How much water have you got there? How long will you
Do you think we should have a look?
I think we should have a look, yeah.
Are you ready for it?
Yeah, let's have a look.
I think you're right.
Come on, I think let's just try this.
Well, are you going to whip this thing out, Kate?
Good, darling.
There we are.
Right, just
How does it feel?
the condensation's on the inside,
Oh, well, that makes sense. That means
and
it has
I would
evaporated.
say that that's exactly the same temperature as it was when it went in.
Well, we try.
Day 3, and Mike Bullivant's taken to the bottle. He's made a fuss and demanded rum. In desperation for something that'll evaporate quickly and cause cooling, he's about to try something he's never tried out of a lab. He's going to make ether. So, goodbye methanol, hello drinking rum and sulfuric acid from a car battery. But ether loves evaporating so much that it's almost impossible to capture in its liquid form. So is ether literally drinking alcohol and battery acid mixed?
Well, it is, but at a specific temperature range. We have to be careful about the temperature of the sand bath. We have to keep it within quite a specific temperature range.
Right.
Yeah. And when the ether condenses,
Yeah.
we feed it through here. And now I thought the ether vapour, because it's such a low boiling temperature, it wouldn't condense until it hit this cold water in here, because this pipe goes round and round, and here's the ether coming out. It goes round this coil, and we collect it. Can you see that?
And there it is. Mike Leahy is absolutely obsessed with improving his suction.
If we put Mike's ether in this bottle, link it directly to this tube, the weight of water in this hose, because we'll have this hose dropping quite a long way, the weight of the water in there will create a vacuum. It will suck on this bottle.
If it works, the suction pump should speed up the whole evaporating, cooling process.
Okay, tough.
Crunch time.
Right, are you ready for the test, Jonathan? Yeah. Okay, so here's a bottle full of water, the same one as we used with the suction device yesterday. I'll just pop the tube down in it. OK, Jonathan, open the valve.
OK. Yeah, it's coming out.
Yeah,
it's lovely.
At this end. It's sucking really fast.
You can hear the tin going in.
It's sucking in the edges of the barrel at the moment. And you can see the level of that bottle. See how fast that's going down?
The super suction works. As the ether evaporates into a gas, it should be literally pulled out of the bottle. And the heat should be pulled out with it.
Gorgeous.
And Mike's not the only one with impressive results.
That glass has melted, and I'm pulling it, and I might even be pulling a tiny tube right now. And there we have some nicely pulled glass. It's actually melted. And that's a brilliantly thin, thin tube. I think it's probably too thin for a thermometer, but I think it means we stand a chance.
So at last she's making progress, but Ellen hasn't produced a single splodge of sunblock yet.
Okay, so see, on the back of some sunscreen products, I've seen anthranolates, and that's the chemical that absorbs UVB rays.
Okay.
Well, I know that there's anthranolates in the oil of lime. I don't know if this is going to work.
Okay.
But if we can have our skin absorb the anthranolates from the lime oil, then when the UVB rays come down, it will absorb into the oil instead of into our skin.
So we bash, mash and squeeze calabash juice, add it to the coconut oil and then add it all to lime oil. Hey presto, sunscreen.
Do you know how cool this will be if it works?
Maybe.
Okay, this is the clay.
We're also trying to make a proper sunblock, a physical barrier that will actually stop the UV rays from touching our skin. The lime potion, a chemical barrier to the sun's rays. And the clay potion, a physical one.
Now we just have to lie here.
It's a sweltering hot day and poor Kathy's still fiddling with her thermometer. She's filling the glass tube with Mike B's leftover methanol, which should act like mercury.
Excellent.
OK, we've got a little hole there. Now, Ellen, do you want to put your sealant in there?
Masterfully done. There it goes.
Oh, fantastic.
All right.
OK. That's that.
Ah, brilliant. Excellent.
If it works, the methanol should contract in the cold and expand in the heat.
So if I put this in here, I hope
It
some of
should-
this is
it
going to
should
come
be.
out of the top. Let's see. Hey, it's moved up already. Can you
Yeah,
see?
yeah, yeah.
Hey! Hey! It's coming out of the top!
Coming out the top, definitely.
really?
The cow doesn't look that impressed. And the thermometers still need to be tested and calibrated to find out which is the most sensitive.
We need different things at different temperatures.
Yep.
We've got some seawater here.
Which is definitely colder than the atmosphere.
We've got the atmospheric
Right.
temperature.
Yep.
We've got body temperature, so
Right.
armpits,
Yep.
and we've got boiling water. So
Okay.
should we throw them in here first?
There are thermometers in there.
What I'm going to do is just kind of mark off the level, because it's so hard to see my liquid, right?
Yeah.
So I marked off with that thing there, the room temperature.
Okay,
You
that's
can
the
see it's gone
atmosphere.
down already, right?
Oh,
so
yeah, I can
I'm going to
definitely see.
move the leaf up here, and that's going to mark off the lower temperature that it reached
Okay.
when it got to seawater, and that's a few millimetres down.
Okay, can you do
There we
mine?
go.
If you
Yep.
press that switch, it was definitely balanced a minute ago.
Okay?
Yeah. Oh, it's definitely going
It
up.
definitely went up, didn't
into
it?
the
It bounced
cold.
up
So it's
into the
definitely that
cold.
water is definitely colder.
Fantastic.
It didn't move much.
So
Okay,
right,
yeah,
next,
Okay.
body temperature.
Okay.
Here we go. There's mine.
Stick that under there.
Great. In here it's about, say, 30 degrees,
Yeah.
and I'm about 30, I should be 37 degrees,
Yeah,
and that's
yeah.
maybe 24, 25.
Maybe 20, I don't know. Yeah.
Yeah. So it's like 7 degrees-ish either side.
Yeah. Well, I can't detect anything on that.
It didn't
That
do
looks
much,
like
did
it's
it?
at the same temperature as the room temperature. Yeah.
And look, I can see mine, and it's going the right way.
Can you give me that back and I'll stick it in boiling water?
Sure.
And at least see how sensitive, what the big change is there. Let's have a look at this.
I can do it this time, Fiona.
Oh, okay. Oh, it's moved a
It
tiny
moved
bit.
towards the hotter, didn't it?
Yeah. I think the range on mine It's bigger than yours.
But I think mine's a little bit more sensitive.
So it makes sense to use yours, really.
I think so.
Well, you won.
It's nearing the end of day 3. Our rough scientists prepare for one more attempt at forcing evaporation to cool things right down. And there's very little time left.
Okay, then quickly before it starts to evaporate, I'll stick this in. Right, okay. Could you put some water on there, Mike? Jonathan? Yeah? Do you reckon you could give us a hand a sec? Do you reckon you could open the vacuum switch at the bottom, the valve? Yep. Okay, all right, now it's got to go in the insulator. Kathy?
Yeah?
Do you want to come and try your thermometer out?
Certainly would.
I'll try and hold that there because I'm worried about it leaking.
Okay. Get this in. Right, I think we should just block up this hole as well. Because we want to...
Crikey, it's pulling... Look at the other side. It's collapsing, the reservoir, the vacuum.
Fantastic.
Ellen! Come on, quick.
Hey, we might...
Have a look at the reservoir.
Close to us.
That's the amount of suction we've got. It's sucked it in.
In the last few moments of sunlight, Mike Leahy has to refill the tin can with water. All eyes are on Kathy's thermometer. Just show me, Kathy.
Okay, this is the marker here that shows room temperature, and this green leaf is showing 0.
Right.
Okay, so it's about halfway down, right?
Yep.
So if it's 30 degrees C out here, that shows 0. It's halfway down, that's 15.
Yeah.
And this isn't actually touching the glass, so it could be colder right next to the glass. So, well, it is colder next to the glass.
Okay.
So we could even be there. Let's have a look.
Are we there?
Let's have a look.
All right. Do we feel good on this?
That's it.
Yeah.
Okay.
Okay, go.
Can you pull it out? Has it got...
Well, you can see the condensate.
There are some little white things on there. Is that polystyrene?
I'm afraid it is. But there is definitely... Can I just prove this to you, Ellen? Is that wet?
Hey, and it's cool.
That's wet and cool.
And it's cool.
It's cool. That's really cool.
Guys, a cooling process has happened, which is great, because Ellen and I need a little bit of cooling. Can I just show you? It's not very attractive, I warn you. Burnt knee, but... Look at this.
This is the kaolin.
Fantastic!
Yeah, so it's a
Wow.
physical barrier. And if you look really closely, you will see that the lime oil had some effect. It just kept rolling off. So there's potential there.
Yeah, it doesn't look very hopeful for getting lots of sunshine today, I must admit.